Okay, here's another example. Here's my function s, and I'm going to identify some points. The first point I can identify is -9, -5. Then I can identify the point -6, 1. There's another point here in -4, 4. 0, 6. And 4, 8. So these points in my inverse function are going to be the inverse ones. I'm going to start graphing these points. -5, 9. -5, 9. 1, 6. 1, -6. 4, -4. 4, -4. 6, 0. 8, 4. So now, remember that my graph has to be symmetric with respect of this line. So when I start drawing my graph, I have to keep that in mind. Where do I start graphing? From one of my extreme points. In this case, this is an easy extreme point. So I'm going to start graphing my point. Notice that if there is symmetry, if for a point in the function, the graph goes away from the line, the symmetric function is going to do the same. If a point gets closer to the symmetric line, the inverse function is going to do the same. So my graph is going to look like this. Notice that my original function gets closer to the symmetric line, so I have to do the same. And that's it. There's symmetry, and we have our graph for the inverse function. Actually, yes. So, remember, identify points in the original graph. Find the inverse points so that you can have points in the inverse function. And then just draw your graph by always checking that you have a symmetry with respect of the original function and the line of symmetry.